Hey everyone, welcome back. In this video we're going to take a couple minutes to talk about some basic graphing skills, and at least this is what I expect for Chem-Phys. Different teachers may have different ideas about what they want on their graphs, so feel free to follow those directions. But what we're going to be doing, at least at the beginning of the year, is we're going to be graphing by hand. And that's to emphasize a couple of very important concepts. Later on in the year, it'll be fine to use Microsoft Excel or other programs to produce graphs, but we're going to start doing them by hand. And there are several components of a, quote, good graph. Whoops. I seem to be making lots of tiny little graphs. Okay. So, components of a good graph. Okay, number one, it has to take up most of the page. We want all of our data to be spread out. We want to see the pattern clearly, and we want to have room to work with the graph. Second, we want to have neat, easy to read labels for both axes, and we want to include units. So for example, for our Zany Zircon Zingers lab, on the x-axis we graphed the distance in centimeters, and on the y-axis we graphed the average time in seconds. So I'm labeling the axes. Next, we want to have a simple scale. So for example, a good simple scale could be something like this: 10, 20, 30, whoops, 30's right there, 40, so on and so forth. Okay, or 0.1, 0.2. That's what I would call a simple scale. In other words, each box is a definite decimal. Okay, so for distance, each box equals 2.5 centimeters. Okay, and for time, each box is 0.02, sorry. Yeah, that's right, 0.025 seconds. Okay, so that's what we mean by a simple scale. And this is going to be important when we come up with equations later. Something that you don't want to do, let me just scroll down for a bit. I don't want to make 3 boxes equal to 7 centimeters, because 7/3 for one box is a decimal that keeps going forever. As a matter of fact, it's 2.33333333 repeating. We don't want that, so try to avoid repeating decimals. Okay, no repeating decimals. And the other thing to be careful of is you also don't want to label the axis with your data points. And I've seen this a lot. So for example, this could be 0, but then someone will label this, okay, here's 0.81, and my next data point was 1.56, and the next one was over here, and that was 3.29. And then on the y-axis, my first time was 0.109, and then here I've got 0.215. You don't want to do that. Okay? You want to avoid doing that. You also want to avoid, and I've seen this a lot, where you make your axis and you make things nice and neat and the tick marks are like so, and then you go ahead and put your data points for the tick marks. So 0.81, 1.56, 3.29, whatever, and then it was I don't know, 0.91, 1.25. So of course when you plot your points you're going to get a beautiful straight line, but that's not really what your data should be doing. Okay, so don't plot your actual data on the axes, if that makes sense. So don't put your actual points there. Okay, it's better to have it look more like this. Okay, you want to have a title, and the title should be descriptive. So this is distance versus time, and if you want to get more fancy, that's fine. Okay, distance versus time. Next, you want to include uncertainties when appropriate. So for example, let's say that we have a value for distance, okay? And we say that we measured distance was 15 centimeters, but our uncertainty for it was plus or minus 2 centimeters. Okay, so the way that we do this is and let's say that for fun the time was equal to 0.1 plus or minus 0.01 seconds. So that data point would be right here, 15 centimeters and 0.1 seconds. In order to show the uncertainty in the distance, we travel plus or minus 2 centimeters on the axis away from the point. So right here is 15, this is 17.5. So we go over about 2, and then we go this way, about 2. Okay, ignore that middle one. And so our points will end up looking kind of like a TIE fighter from Star Wars, especially when we put in the uncertainty for the time. Okay, so plus or minus 0.01 seconds would probably show up kind of like this and kind of like that. Okay, there are ways to do this on the computer later, but for now we need to hand draw them in. Okay, so the next thing is you need to have a smooth curve that tries to hit all points. Or at least goes through their uncertainties. Get rid of this real quick. Okay, so let's say that we have a couple more data points right here and maybe right here. Okay, and we have uncertainties. I won't draw all of them. Okay, so what you want to do, I'll do this in a new color, is you want to try to draw a smooth curve or line that kind of hits all the points. And you have to use your judgment. If it looks like it's a straight line, well then draw in a straight line. If it looks like it's a curve, draw in some type of curve. One thing you don't want to do is do not connect the dots. When you connect the dots, what you're saying is, my data is perfect. You don't want to do this because you know that your data is not perfect. Okay? So if you have a bunch of data points that are maybe here, 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 and here, it's better to draw a nice smooth curve that tries to sort of split the difference rather than connect the dots. Don't do that. Okay, and the last thing, and we'll talk about this in a following video, is to determine an equation for the line or curve. And we'll talk about how to do that a bit later on.